Hi, my name is Andy Ravenna, and I'm a technical trainer for SAS Institute. Today, I'd like to talk to you about how to perform end-to-end modeling, including machine learning in SAS Viya. I'm going to start by giving you a very brief introduction into the analytics lifecycle, and we'll also talk just a little bit about SAS Model Studio. Then I want to discuss with you the data that I'm going to be using for the demonstration. Then I'm going to jump right into the demonstration. The analytics lifecycle consists of three phases. There's the data phase where we get access to our data and begin to understand our data. There's the discovery phase where we begin to build models on the data. And then finally, in the deployment phase, we're going to pick a champion model and we're going to put it into production. Model Studio, which is included in SAS Viya, is an integrated visual environment that gives us a whole suite of analytic tools, and it allows us to perform end-to-end data mining, text, and forecasting analysis. Model Studio is a common interface that includes the following SAS solutions: SAS Visual Data Mining and Machine Learning, SAS Visual Forecasting, and SAS Visual Text Analytics. The data that we're going to be using during the demonstration is taken from a large financial service. They offer things like home equity lines of credit, automobile loans, and other credit instruments. The data has been anonymized and transformed, and it includes a campaign from the bank that ran for 6 months. During the campaign, they offered both direct and indirect promotions. We have lots of descriptor and explanatory data on the customers and their activity, and our primary target variable is binary. It's simply an indication as to whether or not a customer made a purchase during the campaign. So in this demonstration, what I'd like to do is really perform that end-to-end analytics lifecycle, where we're going to start by loading some data into SAS Viya. Then we're going to build some models using pipelines in Model Studio. And then we're going to pick a champion model. We're going to put it into production using SAS Model Manager. Let's go ahead and get started. The first thing that we want to do is get a hold of the data that we want to use in the demonstration and bring it into SAS Viya. So you see I've got a link here from SAS Viya to SAS Drive. SAS Drive is basically what I think of as sort of the home page, where we get started with all of the different functionality that's available to us in SAS Viya. I'm going to log in using the default login. You've probably got your own login back at your office or wherever you have access to SAS Viya. And I am going to opt into the assumable groups as a SAS administrator, just in case I want to do any of those high-level activities. This is going to land me directly into SAS Drive, which is our home page. And what we're going to do is go to the very upper left-hand application menu. And what you and I want to do today is build some models. So when we select Build Models, you can see it's taking us directly into Model Studio. And what we want to do inside of Model Studio is we're going to start up a brand new project. You can see that there are already some other projects that are available to us, but we're going to start our own. I'm going to call this particular project Model Studio Workshop. And we are going to be creating data mining and machine learning objects. So we're going to leave that. You can see the other choices here are if we wanted to perform forecasting or text analytics. Now I want to get access to the data. So I'm going to click on the Browse button. And it turns out that our data is out on the hard drive. So what we're going to need to do is import it. So I'm going to go over to the Import tab. We're going to come down, open up Local Files, and access a local file. And if I go onto my D drive, I've got a folder here. all the way down this path that contains the data that you and I are interested in, we're going to open up the banking partition table. Now, we're ready to import this table. It's a CSV file. And what's happening now is this table consists of just over 1 million rows, or 1 million observations, as we like to say at SAS. And now we're taking those 1 million rows, including all of the columns of explanatory information, and we're going to load it up into data, load it up into memory. So now it's loaded into memory, so it's ready to be used. So I'm going to click on OK. And the other thing that I'm going to do is if I scroll down in this new project window, there's an advanced button. And since we're interested in building several different models, in order to help us pick the best model, we're going to use partitioning. So you can see there's a selection where we can partition the data. And by default, it's split into 3 partitions. You and I are just going to use 2 partitions. We're going to use a training, which is going to be 70% of the data, and validation, which is going to be the remaining 30%. So we're not going to have that third test partition. I'm going to go ahead and save those project settings. Then I'm going to click on Save. And what's going to happen now is Model Studio is going to bring that data in and begin to build some metadata on it. So the project is just getting ready to open. And when it does open, we're going to land on the data page. And on this data page, you can see that it's starting to load in all of the metadata that it's created. We're going to see a little message here at the top that says you must have a target variable. And so in order for us to build our models, we need to identify that target variable. It's B_target. It's a binary variable between 0 and 1, where 1 is an indication that a customer made a purchase during the campaign season. 0 means they did not make a purchase. So I'm going to highlight or select that variable. I'm going to come over here to the roles, and I'm going to identify this as my target variable. And then as soon as I do that, we're going to lose that little message that says, hey, I need a target variable in order to continue. Let's move from the Data tab over to the Pipelines tab so we can start to build our first pipeline. We're going to start with the data node, which represents our data. I'm going to right-click this. I'm going to add a child node. We're going to do some data mining pre-processing. And the first thing that we'd like to do is to perform some imputation. We're going to be looking at a neural network model here. And neural networks really don't have their own way to automatically perform any sort of imputation. It's a model similar to other models that use complete case analysis. So we'd like the software to impute any missing values for us. After we perform that imputation, we're going to add another child node of data mining preprocessing. And here we're going to select the variable selection node. So also, neural networks don't have any way of performing their own variable selection. A lot of times we have many, many columns or inputs into our model, and we want to narrow those down to the most important. So here's what we're going to do. For the variable selection node, I'm going to come over to my variable selection options, and I'm going to change the combination criterion from selected by at least 1 to selected by a majority. Then we're going to identify 3 methods that we're going to use. We're going to leave the fast supervised selection method on. We're going to add in linear regression, and I'm going to minimize that, as well as decision trees. And so those 3 methods will be looked at, and if by majority, so that means if 2 of those 3 methods select an input, then it's going to be included in our model. The next thing that we want to do is add in our neural network. So underneath my variable selection, I'm going to do a right mouse click. I'm going to add a child node, and we're going to move into some supervised learning. I'm going to select a neural network. I'm going to add that onto my pipeline. And then we also want to add in a competing model. So we're going to come back up here to our data node. I'm going to do a right mouse button click, add a child node, go down to supervised learning, and we're going to select a forest. Forests have their own way of performing both imputation and variable selection, sort of automatically by looking at splits. So they don't need those two pre-processing modes. Let's run this pipeline. My model has finished running, so let's start to investigate some of the results. I'm going to start by taking a look at our variable selection node, and we're going to go into the results. You can see we have a variable selection table, and if we expand that, we can actually see which of these variables, our input variables, have been rejected and why they've been rejected. So the reason is a combination of our criterion. So we're going to close the variable selection table, and we're going to open up the variable selection combination summary. This allows us to see exactly why a variable was rejected. So we can see, for example, we have a variable called the demographic of whether or not a particular customer owns a home or not. This was rejected by all three of our methods, the FAST, the linear regression, and the decision tree. And so therefore it was rejected. Let me go ahead and close that variable selection combination summary table. And I'm also going to close the results or output from my variable selection. Next, let's take a look at our neural network. So I'm going to come over to my neural network. You can either right click or you can select the three little dots. We call that the snowman or the overflow menu. And we're going to go into our results. Now, the results for the neural network are going to show us a network diagram for those of you that are familiar with those. They're interesting to look at, but they really don't tell us how to interpret our model. Let's take a look at the iteration plot, which I'm going to expand. And we can see the validation error is decreasing as the neural network begins to learn. In other words, the model is improving its performance on that validation data as our neural network is trained. I'm going to close that, and I'm going to move over to our assessment tab. And you can see we have several different assessment reports. I'm going to scroll down, and I'm going to open up the model fit statistics report. And we have several different model fit statistics. Hopefully you'll find your favorite one. I've got the misclassification rate. I've got the average squared error. I've even got our KS value. So there are lots of different model fit statistics that we can use to help us assess our model. I'm going to close that. And let's go ahead and close the neural network results. Finally, let's take a look at our forest results. So I'm going to click on that overflow menu, go into the results here. And what I'm going to do is take a look at this error plot. You can see we can actually look at this plot by a couple of different ways. We can look at the average squared error or the misclassification rate. But we can definitely see that the error is being reduced as we add additional trees here. And so as you would suspect, the training data, which is this blue line, is always going to improve if we continue to add additional trees. Let me go ahead and close that. I now want to show you how easy it is to integrate open source models into pipelines. And you know, it just occurred to me Why don't I take this Chrome window and move it into full screen mode. This gives us a little bit more real estate to play with and gives us a little better view of Model Studio Workshop. I'm going to come over to my imputation node and do a right click. We're going to add in a child node. Underneath the miscellaneous category, we're going to add an open source code node. I'm also going to right click so that I can rename this open source code node, and we're going to call this our Python forest and click on OK. Then I'm going to right click on the Python forest and we're going to open it. And that's basically where we're going to be able to type in the code. So I'm going to come to the end of line number 16 and hit enter, and it says, hey, put your code after this line. So this is where I want to begin to code my Python forest. Now, I am not a Python coder. So what I'm going to do instead is I have a notepad that is already opened here, and it's a text file, the Python forest code.txt. I'm going to do a right click on that, and then we're going to open that up with the notepad. Then I'm going to do a Control A and a Control C so that I can copy that code. And we're going to go back over here to Model Studio, and starting in line 17, I'm just going to do a Control V. Now I'm going to type in, paste in that forest code. Let's go ahead and save that. And then let's close that. Now we've added the Python code node to Model Studio, but now we also want to tell Model Studio that we'd like to use this node such that it contains a predictive model, and that way Model Studio will output the scored data for us. So I'm going to do a right mouse button click on that, and I'm going to say, let's move this to supervised learning. And then you'll notice that it actually changes the color of that node so that it matches my other models. That's pretty cool and was relatively easy to do. One other thing I'm going to do is I'm going to come down to my model comparison node. I'm going to select it so that it becomes the active item in my interface. And what we're going to do is the class selection statistic. We're going to change this from the default set in the project settings, and what we'd like to do is misclassification of our events. And so this is how my models are now going to be compared. Let's go ahead and run this pipeline. My Python forest has finished running. So now we've got 3 models that we can compare. Let's go to our model comparison node and take a look at the results. And we can see that based off of the misclassification rate, that the forest is the champion model. Let me come over to the assessment pane, and you can see that we also get rock reports. Let's change this from accuracy to receiver operator characteristic chart. And now we can see that in terms of avoiding misclassification, if I mouse over here, it looks like that forest also has the best rock curve of all my models. So probably is misclassification, and if we looked at the KS statistic, it would also probably indicate that the forest model was the winner. Let me go ahead and close my rock reports and close the results from the model comparison node. Let's go over to our Python forest and just investigate what kind of results we get from running that Python forest. And what's kind of fascinating here is if we scroll down just a little bit, I can take a look at my Python output, and that's going to show me that it actually built a forest model and the settings that were used to create that forest. So that's useful. And the other neat thing is if I look over on the assessment panel, you're going to see that we get the same type of assessment output that we do for all the other models that we created in Model Studio. So we get the lift information, the rock reports, as well as that model fit statistics table. Let me go ahead and close that. Model Studio gives us the ability to build multiple pipelines and then compare across those pipelines. So while we're in this discovery phase of the analytics lifecycle, let's add an additional pipeline. Beside the Pipeline 1 tab, there's a little plus button. We're going to call this new pipeline, Pipeline from Template, because we're going to use one of the default templates that comes with Model Studio. I'm going to click on Browse and I'm going to scroll down and I'm going to find the intermediate template for class targets. And these are a whole bunch of default templates that come with Model Studio, so they make it very easy for us to build these pipelines. I'm going to click on OK, and you're going to see what comes inside of that intermediate template. That intermediate template consists of a stepwise logistic, a forward logistic regression, and a decision tree. I'm going to select the decision tree so that I can get access to the options. I'm going to open up the splitting options, and we're going to take that minimum leaf size and bump it up from 5 to 500. That's to get it to run just a little bit faster. Let me go ahead and minimize those splitting options, and let me also go into the pruning options, and I'm going to change that subtree method from cost complexity to reduced error. Now that I've made those two changes, I'm going to run this entire pipeline. My new pipeline is finished running. Let's go in and take a look at some of the results from the decision tree. I'm going to open up the results for my decision tree, and what we're going to see is an interactive tree diagram. You can actually go in and spend time expanding the diagram, looking at the branches and the leaf nodes of the tree, and going in and taking a look at all of the statistics. I'm going to come down to the error pruning plot. Let me scroll down here and also show you, when we expand on that, one of the things that I love is that we do get a little bit of text here that basically tells us, using that validation partition in order to prevent overfitting, the selected subtree was a total of 34 leaves. And we also have the misclassification rate that's there. That's some great information that lets you see exactly what happened with the model. It's also very easy to interpret as well, I think. Let me close the error pruning plot and close the results from the decision tree. And in this brand new pipeline that we've created, I'm going to come down to the model comparison results and investigate those, and we'll see that from these three models, the stepwise logistic, the forward logistic regression, and the decision tree, that based off of the KS statistic, you can see that the stepwise logistic regression is the winner. So it's got the highest KS value there. One thing that's kind of interesting, though, is that if we were to look at the misclassification rate, it turns out that the decision tree has the very best misclassification rate. It's got the lowest misclassification rate. So now, depending on which one of these model fit statistics we would choose, we might get a different champion. So what I'm going to do in the next phase of us investigating these models is I'm going to add the decision tree as a champion to the model so that it will be included. So now I've built multiple pipelines. Let's move from the Pipelines tab over to the Pipeline Comparison tab. Pipeline comparison is going to allow me to compare multiple pipelines. And then we're going to pick the champion of the champions. Based off of the two pipelines that I have, it looks like the forest is the overall champion model with the highest KS statistic. But if we wanted to dig into a little bit more detail, I can select all of the champion models from all of the pipelines and compare them. And if I scroll down, I've got a nice model fit statistics table. And we can see, for example, maybe we look at the misclassification rate. We would want to look at the validation misclassification rate for my stepwise logistic, as well as the validation data for the forest. And we can see that the lowest misclassification rate is held by the forest. Let me go ahead and close the fit statistics window and close the comparison window. You'll remember one of the other things that I wanted to do was I wanted to go back to my pipelines, and originally when we were looking at this particular pipeline, it looked like the decision tree had a better misclassification rate. So let's take this decision tree and let's add it as a challenger model. And when I add that as a challenger model, I can come back over to my pipeline comparison, and you can see that now the decision tree has been added. One of the other really great features of Model Studio Workshop is, or Model Studio and my workshop that I'm doing, is this Insights tab. And what we get is we get a nice project summary. That project summary has automatically generated text that explains that champion model to us, and also the most important variables that are used in that model. If we scroll down just a little bit, you'll see that we also have the most common variables selected across all of our models. So that's really showing me all of those variables that are important to the models that are in our pipeline comparison window. And you can actually click on this little information button to get another nice automatically generated set of text that can help explain what's going on with that particular output. There's also a project notes window, and this is a good place for me to go in and make any notes to myself about what I learned about this particular project. We're now ready to move into our third and final phase of the analytics lifecycle. We started in the data phase by loading our data into memory. Then we spent some time in the discovery phase where we created several different models, and then we discovered a champion model or two that we may want to consider. And now we want to take one or more of those models and deploy them or put them into production. So I'm going to do that by switching over from my Insights tab. I'm going to come back over here to Pipeline Comparisons. And as it turns out, I'm going to be interested in the forest model and the decision tree. And what we're going to do is with both of those models, we're going to register them by going to this upper right-hand overflow menu and saying that we want to register the models. So we're currently inside of Model Studio, and Model Studio will allow us to register those models with Model Manager. What's happening is some metadata is being created in the background about these two models so that when we move from Model Studio into Model Manager will be ready for us to take that and deploy it. So as soon as these two have finished registering, and they just finished being registered, I'm going to close this window. And I'm now going to go to the upper left-hand corner application menu, and switch from build models into manage models. Then I'm going to come over to the projects icon, and you can see there is my Model Studio Workshop. When I open up that Model Studio Workshop, here are the two models that we have registered and are now available to us over here in Model Manager. I'm going to come over to the Properties tab, and in the Properties tab, I'm going to set a couple of options here. I'm going to set my target event value to 1. I'm going to specify that my target level is binary, and then I'm going to choose the output event probability variable as EM_event probability. Let's save these changes that I've created so far. And now I'm going to move over to the scoring tab, where we're going to be able to create a brand new test so that we can test our model in the deployment phase. I'm going to call this particular test scoring example. And then we're going to want to choose the model. The model that I'm going to select is the forest model. Then we need to choose an input table. So I'm going to select an input table. It turns out we're going to need to import the table that we would like to score. So you'll remember that the process of scoring is to take your champion model that you've selected and then apply it to brand new data, either new patients or new customers. And in our banking data, it's basically new customers. I'm going to go to the local files, and I'm going to select, we've got a bank score Excel spreadsheet that I can import. So we're going to import these new customers, this table of brand new customers, into this particular testing item so that we can run a test and see how our model is performing. I'm going to click on OK. I've got everything filled out here, so I'm now ready to click on Run. So that one test is running. Remember, this is the forest model that we created, and you can see here that the status is that it is still running. So we'll wait for the new data to process through this forest scoring. And then as soon as it finishes scoring, what we'll do is we'll take a look at the results. Okay, my model finished scoring. I'm going to take a look at the results. We're actually going to go into the output. And you can see here is the predicted probability that B_target is a 1. In other words, how likely is it that this customer is to make a purchase? You can see that it's only, this customer is only about 8% likely to make a purchase. So they're actually being coded as a non-purchaser, which makes a lot of sense. All right, thank you very much for joining me today and exploring how to perform end-to-end modeling with SAS Viya. I look forward to seeing you next time, and if you have any questions, please leave them in the comments below.